Okay, this is number 1 from your word problems from your review packet. And we're just going to read through the problem. And as we read through the problem, I'm going to highlight any information that I think we might need. Okay, and I want you to underline it as we do this. An ice cream manufacturer produces 2 types of ice cream, the chocolate swirl and the rainbow stick. The chocolate swirl requires 25 liters of milk per batch. So I'm going to highlight that. While the rainbow swirl needs 16 liters of milk per batch. Okay, so we know that we're probably going to have to use that information somewhere. The ice cream manufacturer only buys 400 liters of milk per day. They also know that they must produce at least 5 batches of rainbow sticks per day, and they need to make at most 10 batches of chocolate swirl. They use at most 525 sticks per day, and the rainbow requires 25 per batch, while the chocolate swirl needs 15 per batch. Okay, so we just kind of highlighted any information that we think we might need. So part A says write down the constraints of the graph if the chocolate swirl is X and the rainbow stick is Y. Now, constraints means basically the equations that you're going to use or the inequalities that we're going to use. So let's first write down what they told us in part A. X equals chocolate swirl. So I'm just going to say X equals chocolate. And Y is going to equal the rainbow stick. All right, so we know anytime we're talking about chocolate, we're going to use X, rainbow, we're going to use Y. Okay, so let's look at this first thing up here. The chocolate swirl requires 25 liters of milk per batch. And the rainbow swirl needs 16 liters of milk per batch. And then it says that they only buy 400 liters of milk per day. So we know that this information, we're going to have to use and put this together because they're talking about the same thing. They're talking about how many liters they're going to have to use. So first of all, we know, excuse me, for the chocolate swirl, it's going to need 25 liters per batch, but we don't know how many batches we're going to produce. So the first thing that I would write down is 25 liters or 25 times the amount of chocolate swirls that we do. So I'm going to say 25 times X because X equals the chocolate swirl. Plus, I know rainbow swirl is going to need 16 liters per batch, but again, we don't know how many batches of the rainbow swirl we're going to make. So that's going to be 16 times Y, which is the amount of rainbow swirls. And we know that our manufacturer only buys 400 liters of milk per day. So if this is the amount I need for the chocolate and rainbow, this is going to have to stay less than or equal to 400 liters. Okay, so that's our first inequality. All right, let's look at the next set of information. They also know they must produce at least 5 batches of rainbow sticks per day, and that they need to make at most 10 batches of chocolate swirl. So how do I know that they must produce at least 5 batches of rainbow sticks? Well, rainbow is Y, so I know Y has to be greater than or equal to, because at least means 5 or more. So Y has to be greater than or equal to 5. Then they say they need to make at most 10 batches of chocolate swirl. So at most means less than or equal to. So X, because X is chocolate swirl, has to be less than or equal to 10. Okay. And we have one more set of information. It says they use at most 525 sticks per day, and their rainbow sticks require 25 per batch, and the chocolate swirl needs 15 per batch. Okay, so I know, here's my next inequality. The rainbow sticks. Rainbow sticks require 25 per batch, and the chocolate swirl needs 15 per batch. So let's do the chocolate swirl first, since I put my X's first in this inequality. I know they need 15 sticks per batch, but I don't know how many batches I have. Plus, the rainbow requires 25 sticks per batch, so 25 times my number of batches for my rainbow. And it says they use at most 525 sticks per day. So that means less than or equal to 525. Okay. So these are the restraints for this problem, or I'm sorry, the constraints for this problem, which basically just means your inequalities. Okay, so that's part A. Part B. Draw the constraints on a set of axes and indicate clearly the visible region, the feasible region. So first I'm going to rewrite what we wrote down in part A. I have 25x plus 5y is less than or equal to 400. Then over here I'm going to write the other one. I have 15x plus 25y is less than or equal to 525. And then my other two inequalities were y is greater than or equal to 5, x is less than or equal to 10. So before we can graph these two inequalities and actually have four inequalities altogether, I need to solve for y. So I'm going to take this and I'm going to solve for y. So I'm going to subtract 25x. And I have 5y is less than or equal to negative 25x plus 400. Divide by 5. And I'm dividing everything by 5. So I have y is less than or equal to negative 5x plus, what is that, 80? Okay, so that's 1. I'm going to do the same thing over here, solve for y. I'm going to subtract 15x. 25y is less than or equal to negative 15x plus 525. Divide by 25. Now I get y is less than or equal to 15 over 25. That will simplify down to what? Negative 3/5 x. 525 divided by 25, that's going to be 21. Okay, so now we're going to graph these. So first we have to figure out what we're going to go by. I think I'm going to go by 5s, okay, because I can't go by 1s. Let's see. I may want to do, here's 5, 10, 15, 20. Okay, so on your paper, you go ahead and you need to label your axes. Okay, and this way, I guess I'll do the same thing. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 35, 40, 45, 50. Okay, so I'll give you a minute to get that ready. Okay. Okay, so let's do our easy ones first. Let's do y is greater than or equal to 5. So that is going to be a horizontal line at 5. So here's my horizontal line at 5. Let's see, I'm going to make this a different color. Let's do, we'll do purple. So here's my y. It's greater than or equal to 5. Okay, and I know I'm going to shade above this region, right? So I'm going to lightly shade above. So I know it's all of this. Okay. X is less than or equal to 10. I know that's a vertical line at 10. All right, I'm going to use a different color for this. So at 10, it's hard for me to get a nice straight line. And this is less than. So far I have this portion. Okay. Let's do this one. Okay. When I graph this one, we'll do that in we'll do it in red. Um, 21 is my y-intercept, so I'm about right here. And then negative 3/5 is my slope. So since I went by fives, okay, um, I went here, let's see, if I went right above, so 3, it's going to be kind of, we're just going to kind of have to estimate, okay, but it's somewhere in this region. Okay, so something like this, and that's below this line. So far I have this little region, okay? And then this one, okay, this one I waited on because my y-intercept was 80 and I only went up to 50. So here's what I did to find out where I could start because it's too hard to go all the way up to 80 and then count down. I'm counting down 5, right? So what I did is I plugged in, okay, where am I at when x equals 5? So when I plug 5 in, y is less than or equal to negative 5 times 5. Whoops, let me fix that. So negative 5 times 5 plus 80. So y is less than or equal to negative 25 plus 80. So that's going to give me, what is this, 55? So I know when x is 5, I'm up here at 55. Okay, so I'm going to go ahead and say that's 55. And now I can use my slope was negative 5. So I'm going to go down 1 to the right, I mean down 5 to the right 1, down 5 to the right 1, down 5 to the right 1. Okay, so I have this really steep line because I would be all the way up here at 80. Okay, and I can't go over completely 1 because I went by 5s. Do you see that? 5. So I could probably go over a little bit, down 5 over 1, down 5 over 1. All right, so I have this line somehow like that. And it's going to be less than, so I went to the left of this. So do you see what they all have in common? If I go to the left of this, they have in common this darkest shaded region. It's all this region right here. Okay, so if I had to plot my vertices right there, right here, right here, and right here. Okay, so let's look at part C. Part C says if the profit on a chocolate swirl is, now for some reason everywhere there's a dollar sign, they put an R, so that's a $3.20, and the profit on a rainbow stick is $1.60. Determine the maximum profit for these constraints. So let's write an equation for profit. My profit is going to be $3.20 for every chocolate swirl, and chocolate swirl were X's, plus $1.60 for every rainbow stick. Okay, so now what we want to do is we want to take our, go back to our graph, okay, and we want to take these vertices, plug them in, and see which one is going to give us the most profit. Okay, so this one was 0, and do you remember what it was? 21. Okay, so that's, I'm going to go back on this one and write 1 point was 0, 21. This point right here was 0, 5. So I'm going to write that down. 0, 5. Okay, this point right here, we're going to have to kind of estimate. That looks like it is 10 and maybe 16, somewhere around there. So 10, 16. And this point, right here was the 0.105. Okay, so I'm going to take each of these ordered pairs, plug them in, and see which one gives me the maximum profit. So P equals 320, and I'm going to use this first ordered pair. X is 0 plus $1.60 times 21. So that's going to be 0 plus $1.60 times 21 is 33.6. So the maximum profit on this one is $33.60. Okay, so now let's try our next point, 0.05. $3.20 times 0 plus $1.60 times 5. That's going to be 0 plus $1.60 times 5. It's 8. Now I'm going to use the point 1016. So profit equals $3.20 times 10 plus $1.60 times 16. 320 times 10 is 32 plus $1.60 times 16 is $25.60. So when I add those together, I get $57.60. And then I'm going to use my last point, 10.5. So 320 times 10 plus $1.60 times 5. So that's going to be 32 plus $1.60 times 5 is 8. So that's $40. Okay, so from the points that I got, profit would equal maximum profit $57.60. Okay, that's problem 1.